at examples 3 and 6 here from section 4.3. Basically what we're doing is we're going to be using the first and second derivatives to analyze a function. In this case, the function we'll be looking at is 2 sine of x minus sine of 2x on the interval 0 to 2 pi. And so example 3 is all about using the first derivative to tell us what's going on. And then example 6 is all about using the second derivative to tell us about the function. So we're going to combine them here today. So first things first, let's find the derivative. F prime of x equals constant we use the sum and difference rule, constant multiple rule, and chain rule. And we should get 2 times the cosine of x minus 2 times the cosine of 2x. And now what we want to do is look for the critical numbers in the interval 0 to 2 pi, places where the derivative doesn't exist, places where the derivative is 0. Since we've got cosine functions here, there's no denominators in sight, the derivative will always exist, so our critical numbers are just going to come from places where the derivative is 0. So here's where we have to use, well, I guess we can factor the 2 out. And the good news is we've got the same trig function. The bad news is we've got different angles. So we want to get to the same angle here. We want to get to the same argument. So we're going to have to use an identity. Now, it turns out cosine of 2x has three different variations. You can write it as 2 cosine squared x minus 1. You can write it as 1 minus 2 sine squared of x, or cosine squared x minus sine squared x. In this particular case, since the other term we have involves cosine, it makes sense for us to swap out for the cosine version of this. And so we'll continue on the next page. We've got 2 times the cosine of x minus, and anytime you substitute in math, you should substitute using parentheses because we don't want to lose track of the fact that whatever I plug into here is going to be subtracted. So we'll put maybe brackets. 2 cosine squared of x minus 1. We want to set that equal to 0. And looking inside here, I would have a minus 2 cosine squared of x plus cosine of x, and then a plus 1. So don't forget to distribute the negative in there. And I could factor a negative out, so it's easier for me to try to factor here. So factor a negative 1 out, essentially switching all the signs, plus or minus signs inside. And now I try to factor this like I would any quadratic, so I need to look at trying to unfoil this. I'd have the first factor as 2 cosine x, the second factor as cosine x. Need to combine factors of negative 1 with these, so it looks like if I have a minus 1 here and a plus 1 here, let's check. 2 cosine times cosine is 2 cosine squared, minus 2 cosine plus 1 cosine, minus 1. Looks like we're good to go. And now we've got 3 real numbers that are multiplied together to give me 0. So the only way that's going to happen is if one or more of these factors are 0. So negative 2 can't be 0, so that's out. So it could be that 2 cosine x plus 1 is 0, or cosine x minus 1 is 0. From the first equation, we would get that the cosine of x is minus a half, or we would get the cosine of x is 1. Now remember here, we're working on the interval 0 to 2 pi. All right? So if I'm looking at the interval 0 to 2 pi, So where the cosine x is minus a half, if I think back to the unit circle, cosine is the x-coordinate on the unit circle, so I'm going to be in quadrant 2 or 3. So x is 2 pi over 3 or 4 pi over 3. For the cosine of x to be positive 1, that's going to be right at the endpoints of 0 and 2 pi. And so when I go to make my sine diagram here for my derivative, I'm on a finite interval, so I'm going to go 0 to 2 pi. My x's will be below, my f prime of x's will be above, and I'll put in these intermediate values here, 2 pi over 3, 4 pi over 3. And the f prime of x is 0 at all these points. So now I need to check what's going on in between. So I go back to my derivative here, f prime of x, and I can go ahead and use this factored form because it might be easier for us to gauge plus and minus. So this is the factored form. So we're going to go ahead and write the factored form down here. It's a negative 2 times 2 cosine x plus 1 times cosine x minus 1. And let's just sort of pick some friendly trig values between here. So actually we've got everything kind of marked up here. So here's the 2 pi over 3, the 4 pi over 3, and then the 0 and 2 pi are here. So we just pick something in here, maybe like a pi over 2. We'd have a negative 2 out front. The cosine of pi over 2 is 0. That'd give us a positive in here and then a negative there. So we would have a positive sign there. So the derivative is positive. Between 2 pi over 3 and 4 pi over 3, we could try pi right in there. We'd have a negative there. We'd have a cosine of pi is negative 1. So we'd have a negative 2 plus 1 is a negative. And then we'd have a negative 1 minus 1 that's also a negative. So a negative times a negative times a negative is a negative. And then we could pick like a 3 pi over 2 in here. And we would get a negative times a positive times a negative, which is a positive. And so there it is. So these are the signs, the plus or minus signs of the derivative. So what's going on with my original function? Well, the derivative is positive. That means the slopes are positive, so the function is increasing. And then you can see here the derivative is 0, so it levels off. Then it starts to decrease, levels off again, then it starts to increase. And I should say coming into this, it levels off as well. So the function is increasing from 0 up to the 2 pi over 3. And then from 4 pi over 3 to 2 pi. And then it's decreasing from 2 pi over 3 to 4 pi over 3. And we can see here that since we go from increasing to decreasing at 2 pi over 3, that's going to be a local max. And since we go from decreasing to increasing at 4 pi over 3, we're going to have a local min. So let's find out what those points are. So we got x equals 2 pi over 3. We're going to plug that into our original function, not the derivative, the original function, which is 2 sine x minus sine of 2x. Whoops. So f of 2 pi over 3 would be 2 times the sine of 2 pi over 3 minus a sine of 2 times 2 pi over 3. That'd be a 4 pi over 3. Now the sine of 2 pi over 3 is square root 3 over 2, times 2 would be the square root of 3. The sine of 4 pi over 3 would be negative square root 3 over 2, but we're already subtracting it, so we'd be adding square root 3 over 2. So this is 2 root 3 over 2 plus another root 3 over 2, 3 root 3 over 2. So that's our local max. And now we're going to substitute in 4 pi over 3 to figure out where the local min is. So it'd be 2 times the sine of 4 pi over 3 minus the sine of 2 times 4 pi over 3, 8 pi over 3. Now 8 pi over 3 would go all the way around the circle for 6 pi over 3 and then another 2 pi over 3. So it would end up here in quadrant 2. So 2 times the sine of 4 pi over 3 would be negative root 3 minus another root 3 over 2. So this is minus 3 root 3 over 2. And so this would be our local min. 4 pi over 3, negative 3 root 3 over 2. And so that concludes the first derivative analysis. Okay.